Our fifth problem is again an important problem of Van 't Hoff factor. We are given that 75.2 grams of phenol is dissolved in 1 kilogram solvent whose Kf is given to be equal to 14. If the depression is freezing point is given to be equal to 7 Kelvin, we need to find the percentage of phenol that dimerizes. Now the previous problem which we did was a problem of dissociating of an electrolyte, and this problem is associating of two molecules to get a dimer. Hence, writing the equation for phenol, we have, since it is given that it is dimerizing, so we have two molecules of phenol dimerizing to get H5OH whole twice. If we assume the earlier molecules before the dimerization or the total number of moles to be equal to 1, then this becomes 1 minus alpha after a certain period of time, and this becomes alpha by 2. So after dimerization process is complete, the total number of moles left are 1 minus alpha of phenol and alpha by 2 of the dimer form. So this is equal to 1 minus alpha by 2. Hence our Van 't Hoff factor I is equal to 1 minus alpha by 2, which is the total number of molecules or moles present after the dimerization divided by the total number of initial moles, which is equal to 1. So this is equal to 1 minus alpha by 2. Now the depression in freezing point of the solution or rather the solvent is given to be equal to 7 Kelvin. So we can use the formula delta TF, but remember here there will be a factor of I multiplied to the initial terms of Kf into molality. I'll tell you why this I is getting multiplied to the initial formula. First of all, let us try to get the answer. This I is 1 minus alpha by 2 into Kf, which is given to be equal to 7, into molality is equal to moles of solute, which is equal to 75.2, which is the weight given, divided by 94, which is the molecular mass of this, divided by, or rather the Kf was 14 and this depression of freezing point was 7, divided by the weight of solvent in kilograms. It is given to be equal to 1 kilogram. So this becomes, this 7 and 14 gets cancelled. So this becomes 1 is equal to 2 minus alpha by 2 and 2 gets cancelled into 75.2 divided by 94. On solving, our alpha comes out to be equal to 0.7. This is the value of our alpha obtained from the equation 2 moles of phenol dimerizing to give C6H5OH whole twice. This was 1 minus alpha and this was alpha by 2. So the amount or the number of moles of C6H5OH whole twice or the dimer finally formed is 0.7 by 2, which is equal to 0.35, and hence the percentage of dimer or rather the percentage of phenol that has dimerized into the dimer is equal to 35%, which is our final answer.